Meet El Capitan, the world's most powerful supercomputer. It boasts over 1 million CPU cores and 10 million GPU cores. Sounds impressive, right? But what if I told you that a tiny quantum chip named Willow, just unveiled by Google, can solve certain problems septillion times faster? That's a speed difference so absurd it's hard to even imagine. To put it into perspective, if El Capitan needed as long as the universe has existed to solve a problem, Willow could do it in 5 minutes. Even if you had an El Capitan for every grain of sand on Earth, it wouldn't stand a chance. But before you start dreaming of quantum powered utopias or fearing digital apocalypse, let's dive into the reality of quantum computing. Spoiler alert, it's both revolutionary and deeply flawed. Quantum computers are being hailed as the next frontier in computing. They promise breakthroughs in everything from clean energy and medical research to AI and cryptography. This month, China revealed a 504 qubit superconducting chip, breaking records and sparking discussions worldwide. People are worried. Can quantum computers really crack encryption, rendering our online security useless? Well, not so fast. Quantum computing is still in its infancy, and while the potential is staggering, there's a catch. By the end of this video, you'll not only understand how quantum computing works, but also why it's not quite ready to replace your laptop or supercharge a hacker's toolkit just yet. First, let's talk about how quantum computers differ from classical ones. The computer you're using right now relies on bits, binary ones and zeros, to process information. Think of it like a light switch that's either on or off. Quantum computers, on the other hand, use qubits. These qubits can represent not just a 1 or a 0, but a combination of both at the same time, thanks to a property called superposition. It's like Schrödinger's cat. It's alive and dead simultaneously until you look inside the box. But wait, there's more. Qubits can also become entangled, meaning the state of one qubit is directly connected to another, even if they're far apart. This allows quantum computers to perform multiple calculations at once, exponentially increasing their power for specific tasks. Sounds magical, right? But here's the problem. Qubits are incredibly fragile. Maintaining their superposition and entanglement requires conditions near absolute zero, and even the slightest interference can cause errors. This is why quantum computers are still far from practical for most real-world applications. Google's Willow chip, however, is pushing boundaries. It can identify qubits with high error rates and reconfigure them on the fly, significantly reducing overall errors. It's also achieved a 5-fold improvement in qubit stability, extending their lifespan to about 100 microseconds. That's groundbreaking, but still not enough for most large-scale computations. One of the biggest concerns about quantum computing is its potential to break widely used encryption systems. Algorithms like RSA, which protect everything from your online banking to your crypto wallet, rely on the fact that classical computers would take billions of years to brute force them. But quantum computers, using an algorithm called Shor's, could theoretically crack these encryptions in minutes once they reach around 2,000 qubits. That's not just a technical milestone, it's a potential game changer for global cybersecurity. The good news? We're not there yet. The real bottleneck is error rates. Even China's impressive 504 qubit chip faces significant stability challenges. Until those are solved, quantum computers won't pose an existential threat to encryption. So, where does this leave us? Quantum computing has the potential to solve problems that are currently impossible, from developing fusion energy to creating unbreakable materials and even curing diseases. But it also raises serious questions about privacy, security, and the balance of power in technology. Google's Willow chip and China's recent advancements are important steps forward, but they're just the beginning. The real revolution will come when we can scale quantum computers with low error rates and long-lived qubits. Until then, we're still in the early days of this quantum journey. Thanks for watching. If you enjoyed this video, hit that like button and don't forget to subscribe for more tech news. I'll see you in the next one.